All right. Well, Gemini's taking notes. Cool. All right. Well, welcome. This is actually the first, technically the first in-person monthly meeting for the DPRG. We were going to meet last month, but of course the ice and cold weather stopped everyone from traveling safely, so I had it online instead. We don't really have any set tech talk today, so we have a show and tell lined up. A couple people brought the robots in. I was going to bring a robot in. I totally ran out of time. So we'll go over those, and then we also have a swap meet, and Harold brought in a bunch of goodies for us to go through and see what is there. We also have pizza coming at noon, and yeah. So for those who don't know me, my name is Mark. Last month at the meeting, I was voted in as president, replacing Paul, who's now vice president. Paul will still be doing a lot of the talking and the face of the club, as it were. Meetings that are not difficult, but I have a hard time public speaking. It's like impromptu speaking, so I'll do what I can, and hopefully it makes sense. But yeah, Paul's usually the face and voice of the club. But he's currently out on a sailboat somewhere off of like Africa, somewhere out there. Last week is in like Malta, but yeah, he's on a big family trip, so he's enjoying his retirement. So anyway, there's no real club business to go over. So a quick update from last month. So we'll jump right into a show and tell. So, Mark, you want to show off your butt to everybody? You can get it up here on the camera so we can record it. And feel free to get up and walk around and come hang out, look at it, and get up close. And this is a relaxed meeting. So
I've been kind of showing this at the Tuesday night meetings, and I just brought it out in person. So this is a new chassis that I'm working on.
yeah, we'll get it on the camera.
So it's basically just a 3D printed two-wheel drive robot. Right now it doesn't do anything, but hopefully shortly it will. So I've always been good at doing the design and the 3D printing and all that, and I'm less good at the electronics, so I'm working on that. So this is the basic chassis here. And it basically uses the wheel design on it is it's got a small gear motor in there that basically drives the outside of the rim. The wheel's on a 3D printed bearing. And so it basically everything in here is 3D printed except for the bearing balls are airsoft BBs. So the tires are TPU on both the main tires as well as the jockey wheel.
Mm-hmm.
What is TPU?
It's a different type of filament. It's a flexible filament.
Yeah, it's rubbery. Yeah.
So rather than being stiff, it's got a little bit more flex and has a little bit more grip than like the plastic on like a regular tire.
You printed the stands as well, it looks like.
Yep.
Yeah.
You gotta have a stand, you know.
That's one of the most important things that you have to design when you're designing a new robot is a stand so that you can actually work on it.
So it doesn't run off the table when you turn it on.
Right.
Ask me how I know. Yeah, I think we've all had robots get away from us at some point. That's really cool. What's your what software do you use to design all this in?
Fusion 360 is what I use.
And your printer is what, a Bamboo or
What's that?
what kind of printer?
I've got two main printers these days. I've got a QD Tech Q2 and a QD Tech Max 3.
That's so cool. Like, yeah, I saw it online like a week ago, but seeing it in person, and like, it's just You normally expect like 3D prints when they match up together, like to be rough and not as smooth as that. That's really, really smooth. I
On
love-
the GPU or on other the chassis parts?
No, on the Raspberry,
Yeah.
it's really, really, really smooth. Smooth motion.
Yeah. No, the 3D printed bearings actually worked really well. So here was one of the prototype
Mm.
bearing.
Oh wow.
And you used the airsoft?
Airsoft BBs.
Can't line up.
And so the nice thing about the airsofts is that they're solid,
Mhm.
so they roll real well.
Yeah, are they round?
And they're really well manufactured actually. So they're just about exactly 6 millimeters, and they work really well for bearings, especially if you want to do larger bearings like that. So rather than buying a $20 bearing, you can basically build your own for nothing.
Yeah, that's, I mean, yeah.
Oh, that's just PLA.
Yeah, you. Better printer, I think. Like,
Yeah.
on the cheap.
It's a good place to come in and like get hobbies, like. I want to try that. I want to try that.
Here's an example of about the smallest I can do. This is using 3 millimeter nylon balls.
Wow. That's surprisingly smooth. What's this? Brilliant.
Yeah, I never thought about putting TPU on the caster, but it's probably a good idea. I know like hardware store casters, you know, got a lot of slop. Probably it's caught on the lazy Susan bearing part of it. That's cool.
That is very great.
I saw a thing from this guy the other day. So what I do here is I was looking at the round ball bearings.
Yeah, they're little 3 millimeter nylon ball.
You line up the hole and drop it in.
Yep.
So we had a really cool idea, but I think that they're illegal in the States. He made a bunch of magnet stuff. He made a bunch of things that would just click together in any kind of orientation.
Mhm.
Max, we're like, how are you orienting your magnets that way to make that happen? Because I always screw up. I get them the wrong way, whatever. He goes, this is how I solved that problem.
Pokeballs?
Round magnets.
Yeah, Pokeballs.
So I think they're illegal here in the States because kids like to eat them and then here's your intestines and all of it,
I
bad
think
stuff.
still got them on Amazon. I've bought a bunch of them.
There's another thing.
But it was like really cool. So they orientate themselves as they need to be orientated to match up to where they need to. That's a really
Yeah.
cool idea.
I used them on,
That's very
we printed some D&D like scenery for games, and the same thing. We put them in the print so they fit together and or something. And I got a bunch of them for that. They work really well.
So your bracket for the it's what the ES5600.
Yeah,
That's just like friction fits.
yeah, it's friction fit, so I can slide it back and forth if I need to adjust the positioning on it.
Yeah, I think they want it like a meter away from surface.
It's actually, I found that they're actually really forgiving. So you can be up to like, you can be up to almost 5 millimeters away and you'll still get a good reading out of it.
Yeah.
But what I like about using the 3D printed bearings is one, it's inexpensive. I can make any size bearing I want at any time. And they make it nice and lightweight. And the nice thing about using that I found with the airsoft UVs is because it's the plastic running on plastic. I tried it with like metal BBs from like a BB gun, but those tend to bind up. When they interact with the plastic, they bind up. With these, I can run these. I can put one of these even as PLA. I can run it on a drill all day long, and they'll spin freely. They don't bind up.
I never thought about using airsoft.
Yeah.
I'm sorry, I was listening to my headphones here. So this is, it's got that rotating cool Hall effect thing, so you can watch the wheels turn. That's cool, man.
So what, it's got an A56 in it, so
Yeah.
that basically measures the angle of the wheel. I forgot to bring a screwdriver with me, so I can't take the wheel off to show you, but basically there's a magnet on the other side of the wheel here that basically, that sensor.
It can watch the polarity of it as it goes.
Yeah, and so it basically tells you what the angle
That's
is.
pretty cool.
So it's basically, as the tire rotates, you can basically read at what angle the tire's at. And so I've actually used that in the control, and that's basically, I use that angle to calculate the RPM. To calculate the RPM of the motor, and so I can actually drive the motor at a given RPM. And so hopefully that will allow me to do things like go in a straight line without having to fight the motors and whatnot. It also gives some advantage for if you run into some friction or something like that, it can actually maintain. So if you want to come over here, I can fire this up. It's kind of difficult to move, but if you want to move the camera over here.
I don't know if my cord will reach that far. Get for a long shot in here.
Position sensors, it's either, it's a really high count, it's either 2048 or.
It's 4096.
Yeah. It's per revolution.
Mhm.
It's amazing.
Yeah, so
That's
you
fine.
can actually read about
Yeah.
0.08 degrees is about the accuracy of it.
Yeah.
I mean, that's right up there with all the AV encoding and all that kind of stuff that we do, right?
Probably even higher.
Probably, yeah.
I know,
Certainly way
So
simpler.
I can go ahead
Yeah.
and so right now it's set at 30 RPM, so it's spinning the wheel at 30 RPM. And so I can basically I'll be able to, once I get it wired up, I'm just kind of experimenting with this one to try and get the code going. So I've got it, so you can add friction to it and it'll maintain the speed. So it's basically using that angle sensor to figure out how fast the wheel's moving, and then it basically tries to hold that speed constant. Right now, it's not tuned overly well because I was going to wait to do the final tuning once I get it out in the robot itself, but I just have it rough tuned right now.
That might control the room on.
What's that?
Oh, Pico Pi? Yeah.
It's running on the Pico. And this is running the new stuff that I'm developing for Modbinder, which hopefully I will be a little bit more on in the next few weeks. I just ordered some new boards.
Okay. Sounds cool.
So the event, what this does is it basically the Pico itself, the code for this is basically all the communication and all of that, and the interface here is all auto-generated off of the module itself. And so you basically plug in the cable, connect to it over serial.
Mhm.
It will download the interface for the module and then display it for you so that you can basically do the calls. And also, when you're creating the module, it can also take a specification for your interface.
Yeah.
It'll parse it and automatically generate a Pico project that basically has all of the code ready to go. So it basically creates a class for the module with all of the functions. So you don't have to worry about any of the interfacing to the computer and all of that. And then you can basically chain them together and link them together.
One shot stop.
And so eventually it'll be something along the lines of this. This was kind of the first prototype version of it.
I'm seeing it go a few months ago.
So it's, so basically you can create the various modules, and then you can basically just daisy chain them together. And then you can talk to the whole chain. So for example, so on this right now, I'm linked to this module, and so it basically downloaded the interface and then produced the interface here. If I link to these guys, my motor. So these guys just have a simple link sketch on them at the moment, but I can link into these, and then by essentially running the same program, this will probably fail just because of the fact it's a demo. I can come up here to File, Serial Connect. So what it does is it's talking to all of them now and generating the interfaces for them. So now I've got all three modules are all on their own separate tabs. They're all the same thing, but so I can come in here and I can say on this first module, I'll change it to blink at 100 milliseconds. So now it's blinking faster. I can go to the last module. And I can tell him to go at 500, which I think is what he's already going at. Let's do 1,000.
What is the software again?
This is software that Mark's written.
This is custom software that I'm working on for them.
You wrote it yourself.
So now, so basically these modules you can create. The idea is that you'll be able to create the modules, and for something like, for example, Robbie, you could actually design it all up, and then they all chain together. And the new modules also have the power on them, so that basically what the board gives you is basically the communication to be able to daisy chain them together. It'll also give you a single point of power where you can change power to them, and it'll automatically do the manage the power for you too. So when you're putting together a project like a robot, you can basically break it into pieces and have each module. You can develop each module separately, and then chain them all together, and then it will basically generate the code for you. So the nice thing about these is, as a developer, if you're using the system, once I get it finished, obviously, you'll be able to essentially just define an interface. That'll do it. Whenever you plug in the module, it can basically read that interface back out of the module. So if you wanted to share it, the modules will be easy to share because all you need is the software to read in the interface, and it'll basically automatically generate the Python driver class for you as well for the module. So once you have them all chained together, you can basically you'll be able to say, okay, give me the driver class for each one of these modules, and you'll get a class that you can then put into your main. Simplify the electronics to make it simplify the electronics for people that aren't used to doing the electronics, and for people that are used to doing the electronics to make it easier to share. Because one of the things that you have when you're creating the electronics is if you're trying to create the electronics, you develop something for the microcontroller and whatnot. You develop your custom. Well, chances are you've developed your own interface and all of that. And then if you want to share it, then you have to document that interface and go through all the process of doing that, come up with the driver so that you can basically hand out the driver. So the goal of this is to kind of automate all of that so that if you're a hardware person, you can write your program. You can basically say, this is what I want the interface to do. It'll automatically generate the code template for you to basically develop the module. Once you have the module developed, You can basically package it up and you can hand it off to somebody. They can plug into it, automatically see the interface, automatically generate the driver. You won't have to go looking up, okay, I've got this board, what's the driver for it? You basically just plug in and it can generate the driver on the fly. And so that's the goal of this project. So I'm on the hook for later, giving a little bit more of a talk on that.
There you go.
So once I get things finalized, like I said, I just sent off for the second gen boards yesterday. So hopefully I'll have those in a week or so. And then the other little piece up here is basically, it's the start of the next design for my robot platform. And I'm going to try and do a 2-point system. So basically what these are is, this has a little time of flight sensor in it to basically measure distance. And then they're basically on a couple of servos so that I can pivot them and aim them. And so the goal is hopefully I can do some scanning to scan with a very simple time of flight sensor for measuring distance for what's out in front of the robot. I'm going to try and use this as the eyes of my robot as kind of a low cost LiDAR.
You thinking about using this for 6 kind of thing?
Yeah,
Hopefully. Yeah.
so
That's good.
Still gotta remember, it's gotta be fast.
Yeah.
I'm not worried.
Scott.
I'm not worried about fast. I'm worried about seeing if I can do it. Maybe next year I can go for fast. This year I'm going to be lucky if I can get it to do it.
Yeah, throw that one too.
If I can get it to find a cam with that, I will be impressed. Anyway, it was just it's something I've been wanting to try, and so I'm finally getting around to it. And now that I've been teaching myself how to make custom PCBs. What's that?
What's the range? Detection range?
On these guys, it's about I think it's 300
Centimeters.
300 centimeters.
Yeah.
What's
About
their
3
angular
meters.
resolution?
What's that?
What's their angular resolution? I think it's just a pinpoint, right? Just a single. Is it
It's a fairly narrow cone.
Yeah.
On the whole cone is either included or not.
What's that?
It's either on or off in the cone.
It's on or off in the cone, but basically what it's doing is a distance sensing. And they're supposed to be very highly accurate. I haven't played with them yet, but
I think on lighting missions, how reflective the material is that you're bouncing on, which I know.
well, actually, that's supposedly one of the nice things about these sensors is these sensors aren't as dependent on ambient light or the surface they're reflecting off of.
Mm-hmm.
Supposedly,
Suppose,
what we will find out. It's not you've played with them, right?
yeah,
So
yeah. Any of the sensors, if you get, say you're next to the long board, the 10-foot board, it's a very shallow angle. You may not get a very good reading because it's just
right,
light's not.
because it is a time of flight for getting reflection back. So.
Yeah, so it doesn't get that
But
reflection back.
those two are on motors. You can adjust the angle they have towards whatever you're tracking.
That's
that,
true, yeah.
That was one of my reasons
So
for
you
doing
can
it that
make
way.
sure that you always track the surface normal basically, and you don't get lost easily.
Yeah. That's the idea. We'll see how well I am at implementing it.
Yeah, what's the practice? Yeah. I like little eyeballs. You can get rid of those and mouth.
Chameleon.
And you have a bit controller that makes the two eyes try and track the same points.
That's one of the things I want to do for the can detection. And so what I'd like to be able to do on the can detection is basically have both of them focus in on the can. In theory, if I can get both of them to kind of focus, I can get the angles that they're sitting at. And so therefore I can actually use the angle that they're sitting at to calculate distance as well.
Wouldn't it be
As
the
a
other way
secondary.
around, that you estimate distance, choose an angle for them to intersect at that distance, check whether they both come back positive?
Yeah, that would be one way to do it too. So those are all things that in theory you can do with it, but I have to get have to write the control and get the sensor reading first. But I'm working on it. Those are the general ideas. And so I'd like to be able to do, like, for example, if I'm homing in on a can, is I'd like to have them both basically targeting the can. And then I can basically move the sensors in as I bring the can in. So I can hopefully follow the can a little bit better rather than just doing something like a simple ultrasonic. And I didn't want to put I want to keep the price lower than putting a $100 LiDAR on the front. So I'm really interested in seeing how your system works for it too. You've got a neat system that you've been working on.
Yeah, right now, just it moves kind of in a rectangle on the course, following the edges, or not the edges, the boards.
Yeah, but your sensor can actually triangulate the exact position of your robot.
Yeah. And
So I'm interested in seeing how that actually works on the course.
yeah,
But I don't know what you're doing for the can detection, and I know that that's not your system for the can detection.
yeah, no, I think I'm going to use, I have like two of the older OpenMV H7s, and those work pretty good. Dixie cams work good. You know, both of them would be, well, you could use blob detection on either one. On the OpenMV H7, you can actually do, you know, train it to recognize what a can is, stuff like that. And then there's another camera. It's the MaxCan. I just found out last night there's a MaxCan 2 out now. So,
Of course.
yeah, so that one you can actually train it on the camera. You can actually take photos and basically upload them, take a model for it, download it back in.
Yep.
So it's
Yeah, I thought about using a camera, but I wanted to try something lower tech just for the fun of it.
so kind of what's nice about the camera. The only thing that you need out of it is the X coordinate of the center of the blob of the can, the color for the can, and you can use that to, you know, to steer it. So.
I guess the next thing is, does anyone have any questions on anything?
I was gonna say, too bad, you know, you can rotate them, right? Too bad you can't elevate them.
Yeah.
No, you can't. They're on a, it's basically 2 servos, so
Oh, okay.
you can elevate and you can
Oh, okay.
pivot.
Yeah.
So each eyeball is technically independent, running on 2 servos.
Yeah.
If you want to call them eyeballs, I guess.
Yeah.
Need some like brown to like eyebrows. The eyebrows.
Have to, since it finds it on through.
Yeah, there you go. Positive quiet.
So that's just the test fixture for it. So I'll wire it up to a Pico and try and get everything working.
Yeah, with the 2 sensors, there's kind of 2 lanes that you actually, you know, you can see boards left or right and forwards and backwards, and it's the 2 boards that make up either side of the globe are 2 feet, so roughly 60 centimeters. And so if I try to center on like 30 centimeters, you can tolerate a lot of slop, you know, I may be off a little bit. It's all the way back at 10 feet looking forward, you know, it doesn't take too much to miss the board or, you know, actually look at the goal and
Right.
the space where the goal is, and, you know, think that you've missed where the board is. So it's, you know, so it can move really back and forth a foot. Still get, pretty accurate readings.
My robot would end up being this way with the thing, it'd be all cross-eyed. I gotta figure it out.
So that kind of event, there could be a lot of cans in the way. Depends on how the cans get placed. You can always knock one over and have it put back and then come get it, the next pass or something. But I was trying to get it to go so it didn't have to back up. So it was always facing one direction and only moved forward, backwards, left and right.
Tell the judges meeting and put the can behind you.
Yeah.
Yeah. Yeah. That could happen. Well, I wanted to try to come back to where the last can was found so that, I wouldn't, and I don't know if I could get in a situation where I leave a can behind. Like, you think that situation doesn't exist, so I usually trip you up.
So for those who are new anyway today, in May, I think it's May 23rd, we have what's called the Roborama, which is our indoor event here at the Makerspace. We have it in the interactive room, but we have multiple competitions on that day, varying difficulties. Starting with the basic quick trip, which is like from one square across the room to another square and back, all leading up to 6 can, which is what it sounds like. It's an arena with 6 cans in there, and your robot has to go in, find the cans, remove them one by one.
It works really well.
And we have a few other events. I can't remember the list off the top of my head, but we have a few other events.
These are basically create the size bearing you want. And
It'll be fun to come to if you remember or not. Come along.
Even if
Check it out.
You have to remove, like, when it's
address it.
Yeah, you have to go in,
pick it up.
maneuver the can, you can push it out
So
or run it or carry it.
smoothly, so.
Yeah, to go in, take it, bring it out, drop it, go back in, get another, take it out.
Like the bearing stuff.
Which was, like,
And the
Everything, yeah.
scheme that
Yeah.
I'm using for the races,
It's a lot of fun. Some of the guys are very advanced robots, so can do it pretty quick, but
because the tolerance is built into the way that I do the races. And so the way that I do the races on these,
that's main.
I don't know if we have any whiteboard markers.
Yeah, thank you. Oh, yeah.
So on the bearing races, so on these the bearings, the typical way that you might think of doing the race would be to do a circle for the bearing. And this doesn't 3D print very well and causes all kinds of issues with having to set the tolerance. So the way that I actually do these is I design the bearing with an octagon in which I basically clip the bottoms. And so it's basically, so if you had the full octagon would look something like that on the bearing. But I basically clip the top and bottoms. So that gives you a 45. So this prints really cleanly. The bearings only contact basically on the 3 points here. So the tolerance on the tolerance basically is built into the shape here. And due to the fact that you're only contacting on basically 3 points on each race, it gives you a nice smooth roll to the bearing. And so that's the trick, is to basically use a octagon instead of trying to fit the bearing exactly.
Is
And
cooldown
then-
shrinkage small enough that you could print an octagon on its side and drop the bearing in there while it's cooling off?
You don't really need to. So basically, if you look at the bearing here, all I do is put a line up a circle. It's exactly the size of the ball, because when you print it exactly like the ball, so the 6 millimeter, the tolerance is going to be smaller. 3D printers will always basically print a smaller hole. So you basically, when you push in the bearing, you can basically just push them into the hole. And then basically you just pop in all of your bearings, and they'll generally stay in place because the tolerance on that hole is a little bit smaller. So it's actually a little bit of a snug pop to pop the bearing in. And when you're putting the bearings in, it's only the last bearing that's kind of snug, because you basically pull the race down to the side as you add it in the balls. So they actually build up really easily.
So what kind of beads do you put inside of yours? Are they like just general plastic beads or whatever?
They're airsoft BBs. And then this one is using 3mm nylon balls.
I thought about the coach from yesterday, evening some more using it.
So there's not a chance of the wheel getting
like
torqued
What's that?
all out of where you put them in.
Technically, sometimes with the tolerance, you can have a ball eject, but it's very, very rare.
Oh, yeah.
So if you notice when I designed this, I can't take the wheel off, but I actually have a PCU seal around the bearing. So there's two things. It keeps the bearing in, it keeps the dust on the bearing. So if I wanted to make this for an outdoor robot, for example, I would just make the wheel come back here solid, so there's nothing to get in here, and then you can basically seal it off with a
I would say that
using on
like
the
that's like
inside.
sort of paper smoothing the.
So for an outdoor wheel, you would just make this solid so that nothing can get into the outside, and then you'd be good on the inside. So
Where does this go?
what's that?
Where does this go?
Oh, this is just an example bearing. In the on my robot here, you can just put it in there. So on here, I've got the races basically built into the chassis for the wheel here. I've got the same bearing down here on the wheel. And on here, the bearing is actually on the outside. What's that?
I'm thinking that's changed a little bit, so it'll do.
Probably just the two as
I figure out the dark and light spot where you get things there. Like that.
I'm using.
Oh, okay.
Yeah, comments, your geometry, it's a lot. It's not very reliable.
Yeah.
These guys?
No boy.
They're about $9 for 2 on Amazon. So that's, I'm kind of working and doing this on the cheap.
And I can
What's
track
the
the
result
walls,
for the plot? What do you want to do?
the long walls.
What I'm aiming for is
I'm
to
trying to put the light up in the back here. Because you have that tracking behind it.
Yeah.
Oh, okay, yeah.
You know, that's what I'm-
No,
So that's a real long. About one to do that purpose.
The idea is
Yeah.
to line the cans around the thing, you have to get the can and take it out of the, so you have to get all.
As far as I can tell, like,
I'm not.
Should you push it?
I'm just gonna push it.
maintain your, like, parallel.
So I'm gonna just design a little pusher block.
You know where you are.
Do you find wheels in your?
Oh,
At least my reference to the wall in front of me.
I always think about the wheels, it's got to be, treads are.
Yeah.
And you go down the street, always back down where that point is.
I have designed several robots.
That's fine.
Well, it's like an Xbox. That's actually over.
Okay, yeah.
Yeah, what is that? The center one is the RGB and one's the IR receiver.
What's the programming?
Just using
They have to an API.
I'm basically.
Does give you
Basically, the idea is there's gonna be a couple of
Yeah, it's something like
modules
that.
That's why they think it's a module, they'll drive the,
Yeah, in person, we got people this year.
Yeah,
And the
Pico
module,
yeah.
I'm not sure the actual specs on it.
And, yeah, finding out
But
how
you
many
can go
are
into Raspberry Pi, you basically, if you record that, it'll say that coordinate where the distance is.
Yeah.
The X and the Y.
Have you built
Your
your
mark,
mark?
right? Just get the RGB, just fix it here, and then we'll give you sig where
That
it's at.
does.
There's some figuring out what direction.
Yes, I
It's great, David. I haven't really gotten into how these guys work. Come up here much. I've just been able to take a point and say, yes, point. That's kind of part of the pattern. I need to get a key on all this right now.
Mike's your mark. Yeah.
My background's in-
Well, maybe use this one with the-
I have three directions of motion. I go side to side. So I can use the whole lot, keep it facing forward.
My background is software.
Yeah, when you go to the cool cup there.
And then
they have those
No, yeah, we have some.
Have you used that?
That's the problem with robotics is that it requires all of those disciplines. That's one of the reasons why I'm working on developing this systems, because I want to try to eliminate some of those.
I can't remember. This stuff is dirty back to you. It's 100 motors, like,
Wow.
I'll be big. So I'm working on it. It's exciting.
The idea behind the system here is that it's a way of basically breaking the project up into blocks.
Wait,
And
why?
so,
Why?
so each one of these modules basically has
all
all
of
of
the
the
tools
chain
are
together.
points of the
So
micro.
I can create a module for drive, a module for the eyes, a module for the other
What's
sensors.
the whole idea to keep it like?
And the idea is
Then this one,
the software behind it is basically
and then space
will
will that can
automatically
accelerate well.
generate
And then
the,
it's basically this
the code
phone based app.
so you
There's no
basically
screen, no buttons. And then it's
automatically.
no, it's got a code really one. It's basically, you can use, software to, you drag.
And then you break it up, plug it into the model.
Oh, yeah.
Module actually has a whole
Yeah, all of it was an app on sketch. It was incompatible with.
Hey, Mike!
I have a temporary one.
I think it was somewhere Lego bricks.
I know, no, think of there was a whole ecosystem and competition around the whole system and all that shit. Basically, Vex is taking on my cost right now.
Files. Robotics.
Pretty good.
We can't research the hierarchy.
For example, these are on configured numbers.
Yeah, well, the idea is, the idea is, the architecture is urban area, here, and then use the value of the distance there. Centered with the blob. Here, just again, kind of blind right here.
But I'm a software developer. I do something myself. I use the AI.
It's about, they're quality much better.
This actually has a button, but you know, this pushing is right now. So I can't use this button that's on the back. I have to use cell phone. I've got it. Yeah, that's the other problem. Is, I have to go around, so I just like that.
Oh, it's, this is the one that comes with the Windows driver. It's a really good power shell, but it automatically loads and all the environment variables. Not that I need.
Right on that.
Yeah, I'm not.
These are all.
Oh, that one, yeah, yeah. That was down yeah, I wanted that.
That's a serious looking fault.
But they just, if you talk about just see.
I went to it, but I haven't been right.
I've got 40 hours. My original design has the problem is there's no curb cuts on my back, and it's low all the time. So it's installed, they're all running. I've had multiple people try to take the whole thing apart from scratch. So, and then even if it's on the outside, now it's just plug in the bottom, shoot it out. And I can place them over. So these things are hard.
One of the things that
So I put apart from scratch, and then I figured out the actual
they can run things that.
That's what's happening here. So the controller here has
Five,
has three motor ports and 4 data ports.
so when you have the part where the data ports,
You're basically
linking this control, basically. For example, when you're running the RVM control, I'm trying to do that over time, but might not be able to read because of delays.
Oh, okay.
I'm gonna give it a motion.
So that's
Perfectly working condition. When I'm